on another world while we're all still alive, which would be astonishing. I mean, it would tell you, first of all, what if there's no evidence at all? There was estimated that there were maybe a planet around every 100 stars. Well, now we think, in order of magnitude, there's 10 planets around every star. And this gets into the expression billions and billions. It really is amazing how many planets there must be.
This is going to blow your mind. When we detect structures in the depths of space that seem impossible, we're left with one haunting question. Is the universe flawed? Or are our theories? For 2 years, the James Webb telescope has scanned the oldest, most distant corners of the cosmos with infrared precision, uncovering structures that don't align with our understanding. Its revelations shake the foundations of established cosmology. Some of these cosmic outliers even suggest galaxies as massive as the Milky Way emerged just a few hundred million years after the Big Bang, a time frame that defies logic. But Webb's revelations don't stop with galaxies. Within just 500 to 700 million years after the Big Bang, immense galaxies appeared. These structures, known as universe breakers, contain up to 100 billion solar masses of stars, utterly unexplainable by our current models. The James Webb Space Telescope, or JWST, is a marvel of engineering. This powerful telescope allows us to look deeper into space than ever before. It sees infrared light, which is invisible to our eyes. This special light reveals secrets hidden from ordinary telescopes. JWST has already made groundbreaking discoveries.
Must be out there. And so, as I always say, there's two questions we always ask. And if you meet somebody who hasn't asked these questions, they're lying to you. Where did we come from? And are we alone in the universe?
Discoveries. It has found galaxies so distant that their light has taken almost the entire age of the universe to reach us. These early galaxies are changing our understanding of how the universe formed. But some discoveries are even more perplexing. JWST has found structures that seem impossible according to our current knowledge. These structures challenge our theories about planets, stars, and the very fabric of the cosmos. These discoveries are like pieces of a puzzle that don't quite fit. They are forcing us to rethink our place in the universe and to imagine new possibilities. While galaxies steal the spotlight, rogue planets add to the cosmic puzzle. Detected in the Orion Nebula, these planets, dubbed jumbos, roam without a parent star. Stranger still, these planetary loners are often found in pairs, leaving scientists questioning how they formed and ended up together. Imagine a planet adrift in space, not bound to any star. It wanders the vast emptiness of the cosmos, a solitary world. These are rogue planets, and they are stranger than science fiction. Rogue planets don't orbit stars. They are free-floating objects, traveling through interstellar space alone. They are dark and difficult to see, hidden from our view until recently. How do these planets come to be? One theory suggests that they form around stars like ordinary planets. But then, through gravitational interactions with other planets or passing stars, they are ejected from their systems. Cast out into the void, they continue to exist, unseen and unknown until now. The discovery of rogue planets raises intriguing questions about the potential for life in these dark corners of the universe. And then there's the mysterious black hole discovered in an early galaxy, already a billion times the mass of our Sun, when the universe was just 5% of its current age. The question isn't just how it grew, but how it grew so fast. Rogue planets are incredibly faint and difficult to detect directly. They don't emit their own light like stars. Instead, astronomers rely on a clever technique called gravitational microlensing to find them. And
these are just deep, fundamental questions, and they're within us, and if you want to know the answers, you have to explore space. And everybody, to Heidi's point.
Imagine a rogue planet passing in front of a distant star. Even though we can't see the planet directly, its gravity acts like a lens. This lens bends and magnifies the light from the star behind it. From our perspective, the star appears to brighten as the planet passes by. By carefully analyzing this brightening, astronomers can infer the presence of the unseen planet. The JWST, with its powerful infrared vision, is particularly adept at detecting these microlensing events. Its observations suggest that rogue planets might be more common than we once thought, perhaps outnumbering the stars in our galaxy. Finally, the Hubble tension. Discrepancies in how we measure the universe's expansion leave scientists scratching their heads. Even Webb's recent measurements support a higher expansion rate, hinting that an unknown force could be speeding up cosmic expansion. Our solar system, with its familiar arrangement of planets orbiting the Sun, might not be the norm. JWST has observed planetary systems that challenge our understanding of how planets and stars form. In these systems, planets aren't orbiting stars. Instead, they are locked in a gravitational dance around strange objects called brown dwarfs. Brown dwarfs are failed stars. They are larger than planets, but not massive enough to ignite the nuclear fusion that powers stars. These brown dwarf systems are different from our own. Brown dwarfs are much cooler and fainter than stars. The planets that orbit them experience a very different environment than Earth. Brown dwarfs and their unexpected families. Brown dwarfs are fascinating objects in their own right. They occupy a kind of celestial middle ground between stars and giant planets. They are too small to be stars, but they are still much larger than any planet we know of. Despite their failed star status, brown dwarfs can still host planetary systems. JWST has observed planets orbiting brown dwarf binaries, where two brown dwarfs are locked in a close orbit around each other. These discoveries are changing our understanding of where planets can form and exist. They show that the universe is full of surprises and that our models of planet formation are still being refined. The planets in these
It is very reasonable that we will find evidence of life.
Systems are likely very different from the planets in our solar system. They experience different temperatures, different levels of radiation, and different gravitational forces. The enigma of jumbos. A cosmic puzzle. Within the Orion Nebula, a stellar nursery where stars are born, JWST has discovered something truly remarkable. These objects, nicknamed jumbos, are challenging our understanding of the boundary between stars and planets. Jumbos are enormous, even larger than the largest planets in our solar system, but they are not stars. They lack the mass to ignite the nuclear fusion that makes stars shine. These objects are shrouded in mystery. Their large size and relatively cool temperatures defy easy categorization. They exist in a kind of limbo, too big to be planets, but not quite massive enough to be stars. Jumbos. Failed stars or planetary giants? The discovery of jumbos has sparked intense debate among astronomers. What are these enigmatic objects? Are they failed stars, objects that almost became stars but fell short? Or are they something else entirely? One theory suggests that jumbos formed like stars, from collapsing clouds of gas and dust. But for some reason, they didn't accrete enough material to reach the critical mass needed for nuclear fusion. Another theory proposes that jumbos are actually supersized planets, formed through a process similar to how planets form around stars. But if this is true, they would be the largest planets ever discovered. The mystery of jumbos highlights how much we still have to learn about the universe. These objects challenge our existing theories and force us to rethink our understanding of how stars and planets form. Universe breakers. Challenging cosmic dawn. JWST's ability to see
Of life. That would mean, wow, we are unique in a way that's literally hard to imagine. But the other thing, it's very reasonable that we'll find life. Just think what
into the distant past has revealed something astonishing. Galaxies that shouldn't exist. These galaxies, nicknamed universe breakers, are so massive and mature that their presence in the early universe defies our understanding of galaxy formation. According to our current models, galaxies formed gradually over billions of years. But these universe breakers appear fully formed when the universe was still in its infancy, just a few 100 million years old. This discovery throws a wrench into our understanding of the early universe. It suggests that our models of galaxy formation are incomplete, and that perhaps some other process, as yet unknown, was at work in the early universe. The early universe, a realm of surprises. The early universe was a time of incredible change and upheaval. The Big Bang, the event that marked the beginning of our universe, occurred about 13.8 billion years ago. In the aftermath of this cosmic explosion, the universe was a hot, dense soup of particles. Over time, the universe expanded and cooled. The first atoms formed, followed by the first stars and galaxies. But the details of this cosmic evolution are still being pieced together. JWST's observations of the early universe are providing valuable clues. The discovery of universe breakers suggests that the early universe was a more complex and dynamic place than we once thought. Hubble Tension, a cosmic conundrum. The expansion of the universe is one of the most fundamental concepts in cosmology. Edwin Hubble's discovery that the universe is expanding revolutionized our understanding of the cosmos. The rate of this expansion is called the Hubble constant. But there's a problem. Different methods of measuring the Hubble constant give us different answers. This discrepancy is known as the Hubble tension. On one hand, measurements of the cosmic microwave background radiation, the faint afterglow of the Big Bang, suggest a slower expansion rate. On the other hand, observations of distant supernovae
It would be like Copernicus or Galileo. It would be just fundamental. It would change the way everybody feels about being a living thing.
Exploding stars suggest a faster expansion rate. This tension could indicate a fundamental flaw in our understanding of the universe. It might point to new physics beyond our current models, such as modifications to our understanding of dark energy, the mysterious force thought to be driving the accelerated expansion of the universe. A universe of mysteries, the quest continues. The James Webb Space Telescope is a testament to human ingenuity and our insatiable curiosity about the universe. Its groundbreaking observations are pushing the boundaries of our knowledge, revealing a cosmos that is both awe-inspiring and deeply mysterious. The discoveries of rogue planets, unexpected planetary systems, jumbos, universe breakers, and the Hubble tension highlight how much we still have to learn. Each new finding is a piece of the cosmic puzzle, helping us to assemble a more complete picture of the universe and our place within it. As JWST continues to explore the cosmos, we can expect even more surprises and challenges to our understanding. The universe is full of wonders, waiting to be discovered. The quest to understand our place in the cosmos is far from over. It is a journey that continues to inspire and challenge us. The cosmos has been our most powerful teacher, but the James Webb Telescope reveals that we might just be scratching the surface. Are there forces and fields we've yet to discover? Could our models be lacking essential truths about the universe? Stay tuned as we explore the ever-evolving mysteries of the universe. Like, subscribe, and don't miss out on the latest revelations from beyond our planet. See you next time.